Hello, this is lesson 6.4, matrix operations. So here we have matrix A, and it says give the order and requested elements. So the elements are the numbers inside the matrix. So our order for matrices is the same thing as the size of it. So and the way we figure out the size is that we do rows times columns. So here, if we look at, we've got 1, 2, and 3 rows. So the way we usually mark them is row subscript 1, R subscript 2, and R subscript 3. So we have 3 rows, and then we've got column 1, column 2, column 3, and column 4. Okay, so when we go and look at the elements here, so element A23, again, it's going to be row first and then column. So row 2 is this one right here, and column 3 is this one. So row 2, column 3 element is going to be 8. Now the next element, 3, 4. So row 3 and column 4 is going to be 12. Next element is 1, 1. So row 1 and column 1, that's going to be 1. Next element is row 4, column 3. Well, if we look at row 4, we don't have one. So this does not exist. Okay, two matrices are equal if they are the same order or the size, and the corresponding elements are equal. So we've got pairs here, and we need to give, let me just do this so that we're separating them. Give the order of each matrix and determine if they are equal. So again, order, remember it's rows times columns. So this first one is going to be, we've got 2 rows and we have 1 column, so 2 by 1. Well, this on the right side, it's got 2 fractions, so it has a half and 5 over 2. So again, it has 2 rows and 1 column. So this is row 1 and this is row 2. Here, row 1 and row 2. And then we've got column 1. So these are equal. These next ones on the right, again, we've got row 1 and row 2. So we've got 2 rows and then we've got 2 columns. So it's 2 by 2. Same thing on the right. We've got row 1 and row 2. And we've got column 1 and column 2. So these are both 2 by 2. So they are equal again. Okay, next one. We have 1 row and 2 columns on the left. On the right, we have 2 rows and 1 column. So this is a no. They are not equal. Okay, so on the left here, again, we've got 2 rows and 2 columns. So we have a 2 by 2, and the same thing on the right. So 2 by 2. So these two are equal. Now, remember what it said here, the corresponding elements are equal. So if we look at the left one, we've got x, y, and z, or we've got y minus 1, and x and z as the elements. So the corresponding elements are the same. So our x the corresponding element is 1, so our x is going to equal 1. For z, the corresponding element is 2, so z is going to equal 2. And then we've got y minus 1, the corresponding element is 3. Y minus 1 equals 3. We can solve for y by adding 1, and we get y equals 4. Okay, next, find the values for each of the variables so that the matrices are equal. First, we need to double check that the order is the same. So if we look at the left and the right, both of them are 2 by 2 matrices. So the corresponding elements are going to be equal. Okay, so we have an x, and the corresponding element on the right is 1. So our x equals 1. Y plus 1 is on the right. Hold on, let me write it here. Y plus 1, and that, the corresponding element is 2, so that's going to equal 2. So when we move the 1 to the right, we get y equals 1. For z, we have z plus 1, and the corresponding element is 2z minus 1. So now we're going to solve for z. I'm going to move the z to the right. So 1 equals z minus 1, and then add 1. So I get 2 equals z. So our z is 2. Okay, so let's go ahead and look at element 1, 1. Well, that one, we can look at either one is going to be a 1. Element 2, 2. So the second row and the second column. So z plus 1, and our z is 2, so 2 plus 1 equals 3. And now we might want to double check that we get that same 3 from 2z minus 1. So 2 times 2 minus 1, 4 minus 1 is 3. Those are equal, so we know that we did the calculations correct. So our element 2, 2 is going to be 3. Now, next element is row 3, column 1. Well, we don't have a row 3 here, so this does not exist. Okay, next one, we're going to look at matrix addition. So you can add or subtract matrices as long as they are the same order or size. We use both of those words, and that's why I keep both of them here, by adding or subtracting corresponding elements. And matrix addition is commutative, so 3 plus 2 is the same as 2 plus 3. Now, remember that subtraction is not. Okay, we've got matrices A and B given here, and we're going to find the following sums. So we're given, our first one is A plus B. So what we're going to do is we're just going to write negative for the matrix right here, our matrix A, and then we're going to add matrix B to it. Now, notice one thing that I did not point out here on this page, is that if we are talking about matrices, we use capital letters. When we're talking about elements, it's a small case a. Okay, so what we're going to do here is we're just going to add the elements, the corresponding elements. So negative 4 plus 7 are the corresponding elements here. And then 3 minus 3, 5 plus 2, negative 2 minus 5, like this. And they stay in their corresponding spots. So we get 3, 0, 7, and negative 7 is our A plus B. Okay, now the next one is B plus A. So here we said matrix addition is commutative. So it doesn't matter if it's 3 plus 2 or 2 plus 3. So the same thing here. It doesn't matter if it's A plus B or B plus A. Our answer is going to be the same. So these two here are equal. So we got that answer already here. 3, 0, 7, and negative 7. Okay. Next one is going to be A minus B. So we're going to subtract. So our matrix A is negative 4, 3, 5, and negative 2. And we're going to subtract matrix B from it, which is 7, negative 3, 2, and negative 5. Now, we need to remember that we have this subtraction right here. So when we subtract the corresponding elements, negative 4 minus 7, 3 minus negative 3, 5 minus 2, negative 2 minus negative 5. So there's our matrix. And now we do the calculations. Negative 11, 6, 3, and 3. And that is our matrix. Now, one of the things that we did not do that we should have done in the very beginning is check that these are um, same order and same size. So they are this matrix A is 2 by 2 and matrix B is 2 by 2. Okay, so let's move on to the next one, which is B minus A. Now, remember that these two are not going to be the same because subtraction is not commutative. So we're going to write B first. 7 minus 3, 2 minus 5. Subtract matrix A from it, negative 4, 3, 5, and negative 2. So 7 minus negative 4, negative 3 minus 3, 2 minus 5, and negative 5 minus negative 2. So 11, negative 6, negative 3, and negative 3. So you can see, so that's that negative sign right there is with the 3. So what happened here if we compare these? The signs flipped. But again, you can't think that A minus B and B minus A is the same thing. Okay, next one we're going to define. So 0 matrix, all entries are 0. So there's an example. Additive inverse, matrix A plus negative matrix A is going to equal 0. So if A is matrix A is negative 4, 3, 5, and negative 2, what is going to be negative matrix A then? We're going to flip the sign, so it's going to be 4, negative 3, 5, sorry, that's negative 5, and 2. So we change all the signs of each one. Okay, next we're going to go ahead and look at scalar multiplication. So what this means is that we are multiplying a matrix by a real number. That is the scalar. This is not the same thing as matrix multiplication. Note that. We are not going to do matrix multiplication in this course. But again, you have to make sure that it's not the same thing. Okay, so let's go ahead and look at, we've got our matrices here, and we need to first figure out the order. Um, our matrix A has one row and three columns. Matrix B has one row and three columns. Matrix C has three rows and one column, and matrix D has three rows and one column. Okay, we're first going to multiply matrix A by 3. So this is our matrix A. All we do is we do 3 times 3, 3 times 5, and 3 times 8. So we multiply each of the elements by the number in the front. So 9, 15, and 24. That is 3 times matrix A. Okay, the next one is -4 times C. So we're going to take our matrix C, which is -3, 5, and 6, and do the exact same thing. So multiply each one of the elements by -4. So we get -4 times -3 is 12, -4 times 5 is -20, and -4 times 6 is -24. Okay, next one is going to be half times B. So our matrix B is 3, -1, and 6. We're going to multiply each of these elements by a half. So we get 3 over 2, -half, and 3. Next, we're going to do matrix C minus 2 times matrix D. So our matrix C is going to be -3, 5, and 6. And we're going to subtract 2 times matrix D, so 4, 7, and 2. Order of operations, we have to do the multiplication first. So 2 times 4 is 8, 2 times 7 is 14, and 2 times 2 is 4. And now we do the subtraction. -3 minus 8 is -11. 5 minus 14 is -13. 6 minus 4 is 2. No, 5 minus, hold on. 5 minus 4 is not 13. 5 minus, no, my 5 minus 14. 5 minus 14 is -9. Not sure where I got the 13 from. Okay, next one is going to be 2 times matrix B minus C. So our matrix B is 3 minus 1 and 6, and that shouldn't, it's a -1, like this. And our matrix C is -3, 5, and 6. So now if we look at these, um, well, first we would multiply. So we get by 2, matrix B. So we get 6, 2, and 12. Now, looking at these two, oops, that's a 6 right there. Um, this one is 1 by 3, and this one is 3 by 1. So these two are not same size. So that means that this is not possible. Okay, next one here is -2 times matrix B plus matrix A. So -2 times 3, -1, and 6 plus matrix A, 3, 5, and 8. So we do the multiplication first, not -2, -6, 2, and -12. And then we add the matrix A, So -3, 7, and -4. Okay, write one example that does not exist. So looking at our matrices up here, A, B, and C, what would not exist? So one example would be to, for example, add or subtract the matrices that are not the same size. So for example, I could do 2 times matrix A plus 3 times matrix, not B, C. Matrix A is 1 by 3 and matrix C is 3 by 1. So not the same size. Okay, then we need to write one more example that does exist. Okay, so we're gonna pick the ones that are the same order. So for example, A and B. So I could do 2 times A plus 3 times B. This is 1 by 3, and this is 1 by 3, so that is possible. Okay, so let's go ahead and look at finding the missing x. Um, so if we look at matrix A, it is 2 by 2, and matrix B is 2 by 2. So in our first example here, let me just make sure that I don't cross that. Our first example here, we've got 2x plus a equals b. Now, in order for us to add the x and the a, what order does it have to be? It needs to be the same as A, matrix A, so it needs to be 2 by 2. So we know that that's what we're looking at. Okay, so how are we gonna go and do this? We're gonna go ahead and solve for the x. So we're gonna subtract matrix A for both sides, just like we do in solving equations. Then we're going to divide by 2. So we get x equals half B, matrix B minus matrix A. So what we're going to do now is we're going to go ahead and do this calculation first. So B, matrix B minus matrix A. So -10, 1, -9, 17, minus 2, -8, 0, and 4. So -10 minus 2 is -12. 1, we've got two negatives that become positive. 1 plus 8 is 9. -9 minus 0 is -9. 17 minus 4 is 13. Next, we're going to take this half and multiply the matrix that we just got by a half. That'll be our x. So half times -12, 9, -9, and 13. So -6, 9 over 2, -9 over 2, and 13 over 2. So this is our x for this first one. Okay, we're going to do the same thing over here. So we're going to add a to both sides. We get 3 times x equals a plus b. We're going to divide by 3. So we get x equals 1/3 a plus b. So what we need to do first, again, is add matrix A plus matrix B. So 2, -8, 0, and 4 is matrix A. And then our matrix B is -10, 1, -9, and 17. we're adding these. So 2 minus 10 is negative 8. Negative 8 plus 1 is negative 7. 0 plus negative 9 is negative 9. And 4 plus 17. Um, hold on. 4 plus 17 is 21. Okay. Now, this is the a plus b. Now we're going to multiply that by 1/3 to get our x. That's a positive 21. There we go. Okay, so we get negative 8/3, negative 3, negative 7/3, and 7. And that is our x here. Okay, that's it for this lesson. Let me know if you have any questions. Bye.